Now let us deal with some examples involving the definition of logarithms. So example number 1, write log to the base c of the argument c is equal to the exponent y. So a while ago, or in the previous slides, in the previous video, I told you that log base b to the argument x is equal to y, and this is interchangeably expressed into the expression b raised to y is equal to the argument x. So our b here is the base. This is our base, and this is our exponent, and this is our argument. So this is the argument, okay? Now in our example, we are to write the log of the base 5 of the argument c to the exponent a. So taking all those things in consideration, we have the base 5. So we are going to write base 5 here. I need a better 5. So base 5, and what is our exponent? Our exponent is a, and this is equal to the argument c. So this is how you write the log expression in exponential form. Okay? Example number 2. Write z4 or z raised to 4 is equal to m in logarithmic form. So this is the opposite of the previous example. In the previous example, we are asked to get an exponential form given a logarithmic form. Now in this example, we are going to get the logarithmic form in terms of, or from an exponential form given. So first we have to identify what our base is. And our base here is equal to z. Okay, because it's the one raised to an exponent. And our exponent, of course, is equal to 4. Okay, and our argument is equal to m. So taking these all nodes together, we could get the expression for our logarithmic form. Therefore, we begin by writing the log. Okay, writing the log notation. So log of, okay, that's better. So we have log to the base 4 of the argument m is equal to, we have, okay, our base is z, I'm sorry. Okay, so log to the base b, or z, I'm sorry, okay, of the argument m is equal to the exponent 4. So this is the answer for this example. Okay. Well, now let's go to the properties of logarithms. A while ago, in these examples, okay, we have done something like, for example, we multiplied the two numerical values 4 and 7, and we took their logs, but out of nowhere I just wrote something like this, and then we have the operation in the middle, which is plus. So now to give you the reason, these are the properties of logarithms. These are standard properties. Okay, so the first one is the logarithm of a power. So what is the logarithm of a power? So consider log of a base b of the argument x raised to y, and that will be equal to log or y times log b x. And verbally, we could say that the logarithm of a power equals the power of the exponent. This is, or equals the product of the exponent and the logarithm of the base. So this is our exponent, and the product of the exponent and the logarithm of the base. Where is the logarithm of the base? The log of the base is log bx. Okay? Is equal to the logarithm of the certain power. Okay? What about the logarithm of a product? The logarithm of a product is just equal to the sum of the logarithms of the factors. So if we have arguments which involve x and y, in this case we have xy, then the logarithm of the product of xy is equal to the logarithm of the individual factors. So we have log bx plus log by. And the third one is the logarithm of a quotient. So this time it's a quotient. So what is the logarithm of a quotient? The logarithm of a quotient equals the logarithm of the numerator minus the logarithm of the denominator. What is our numerator here? It's log x, or x. And our denominator is y. So we take the logarithm of the numerator, which is log bx, and then we subtract the logarithm of the denominator, which is log by. Okay? So these are the properties of logarithms. So we take these examples for the properties, showcasing the characteristics of the properties. So this example is asking us to show numerically that log 3 plus log 5 is equal to log of the product of 3 and 5. So how are we going to do this? Let us write the original expression. Log 3 plus log 5 is equated to the log of 3 times 5. Okay, what is log 3? So get your calculators and let us get the value of log 3. So our log 3 is equal to, rounding off to the nearest 10,000ths, or 4 decimal places, 0.4771, plus what is log 5? This is just 0.6989. And what is log of 3 times 5? This is just a log of 15 actually, right? So what is log of 15? Okay, log of 15 is equal to, it's 1.1761. So 1.1761, rounded off to the nearest 10,000ths. Okay, so how about the left expressions? Okay, so 0.4771 plus 0.6989. This just gives us 1.1761 rounded off to the nearest 10,000ths. Now these are, okay, so now we get the expression similarly. So we now prove that log 3 plus log 5 is equal to log of the product of 3 and 5. Example number 4, prove algebraically that log b xy is equal to log bx plus log by. Okay, so these are, notice that log bxy is divided into two different expressions. So first, let us say, a is, or we take another letter because we already have a and b there. So let c is equal to log bx, and therefore our d, okay, is log by. Now writing these log expressions into exponential expressions gives us b raised to c is equal to x, and this one gives b raised to d is equal to y. And because we want to get an expression for xy, then what we're going to do here is to multiply our x to the y. So therefore, if we multiply x to the y, we will also multiply bc to bd, and that gives us xy. Okay? So take note that this expression here has the same base, so they have similar base b. And according to algebra, okay, if you have the same base and they are raised to different exponents, then the product of those bases is actually the base times the sum of the exponents. So it will be b raised to m plus n for this expression. Now in our example, we have b raised to c times b raised to d, giving us b raised to c plus d, right? And that's equal to xy. Now taking the logarithmic form of this expression here, the equation of which is now exponential in nature, we will have what do we have here? Okay, so our base is b, so we will have to write log of the base b, and our exponent is xy, and our exponent is c plus d, and our argument here is xy, so log b xy is equal to, let's put a parenthesis in between xy. So log to the base b of our argument xy is just equal to the exponent c plus d. And what is our c? Our c is log, so let us write here first, and this is equal to okay, log of b xy is equal to c, and our c is equal to log bx, and our d is equal to log by. Therefore, we proved that indeed log to the base b of xy is equal to log to the base b of x plus log to the base b of y. Okay, so this is the answer for this example. Example number 5. If log 3 plus log 7 minus log 5 is equal to log of a certain expression, what number goes in the blank? Okay, considering the properties, then we should write the expression first, original expressions. So log 3 plus log 7 minus log 5 is equal to unknown. And notice that I've told you in the previous lectures or in previous videos that if you can see a certain base written, so in this case you can see a base here, okay? There's nothing written here. So these types of logarithms are actually in base tens. So automatically these bases are tens. So applying the properties, first we need to group. We're going to group the first logarithms, okay? And that gives me a property which is the product of the logarithms, right? So this two expressions here can be written as log of 3 times 7. Am I correct? So minus log of 5. And that will give me, because we could see another operation here. So we are through with this operation. That means it's a product of the two factors. But now I have negative, which means that it's a quotient of the expressions. So now I will have log of, now let me write this as 21 anymore, okay, divided by this one, okay, so log of 21 over 5, okay, so therefore I could write this logarithm expression here as log of, well, I divided 21 to 5, so I will have 4.2. And log of 4.2 is equal to, so log 4.2, that's equal to 0.62, okay, 6232, rounded off to the nearest 10,000. So that is my answer. So what is in here? What is in the blank here? The one in the blank is actually 4.2. Okay? This one. Okay? And the answer to the whole logarithm expression is 0.6232. Okay. So we have another example. Now we are going to solve logarithmic equations. And how do we do that? Okay. Now we have to think in mind the properties of the logarithm. So basically, logarithmic equations are revolving around those properties. And by making use of those properties, we should be able to solve the equations of any logarithmic equations available. And logarithmic equations, okay, involve these base 10 logarithms and the logarithms with the base e. Okay, so in this portion, I'm going to tackle some lectures about the base e logarithm. So we have two types of logarithm. We have the common logarithm, and these common logs are the logarithms with base 10. So these are log of x, something like that, okay? We have a base 10 here. And another one is the natural logarithms. And these natural logarithms are, and they are expressed in terms of ln. So for example, ln of x plus 1. Okay? So to counter these natural logarithms, normally we raise these logarithms, these natural logarithms, we raise it with a base e. So, for example, we have e raised to ln of x plus 1 just gives us x plus 1. And this is a property of natural logarithms. And this is covered in the previous lesson, which is entitled the change of base property of logarithms. So in this case, in this expression here, we have 4 minus 3 ln of x plus 5 is equal to 1. So first, what we need to do here is to rearrange the equation to isolate x plus 5. And how do we do that? Okay, so we isolate the expression with x plus 5 with the expression x plus 5. So this gives us negative 3 ln of x plus 5 will be equal to 1. And then we transpose the 4 to the right, so that gives us minus 4. And dividing both sides by negative 3, so this is divided by negative 3, this is also divided by negative 3, we will get ln of x plus 5 is equal to, this one gives you negative 3. Okay, so negative 3 divided by negative 3 is just 1. Now we are ready to transform the given natural logarithm in terms of the base e. So therefore, this expression, natural logarithm expression, will be transformed using the base e property of natural logarithms, which is again a definition of the logarithms. So we will have e raised to ln of x plus 5 is equal to e raised to 1. And this property just gives us the value x plus 5. So this is x plus 5 will give us e on the other side. And e has a corresponding value. So look at your calculator. Take your calculator and look for the word or the expression e raised to a blank there. And in your calculator, it could be taken or it could be evaluated by pressing the shift, and you can see the ln expression there beside the log. So just press that one, shift of the natural logarithm ln will give you e raised to a certain box, and just put 1 on the box. So that gives us x plus 5, and e raised to 1, or just e, is equal to 2.7182, etc., etc. So it is infinite. And our x then is equal to, this is negative 5. We transpose this one here, plus 2.7182. So our x now is equal to okay, we subtract that from negative 5, so that will give us negative 2.2817 rounded off to the nearest 10,000s. Okay, so this is our answer.